Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out 16 practice problems that are going to closely mirror what you'll see in the Arithmetic Reasoning Subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB. In order to get the most out of today's video, I strongly encourage you to work out these problems on your own. That is, after I read a question, you should pause the video, attempt to work out the problem on your own scratch paper, and then resume playing the video to check your solution. As a reminder, you're not allowed to use a reference sheet or a calculator on the ASVAB, so it behooves you not to use any of those things as you complete this practice test. In the description of this video, I'm going to include timestamps that are associated with each question. Next to the timestamp is going to be the topic that the question's testing. And next to the topic, you'll find a link to one of my videos where I discuss that topic in greater detail. So if at any point you get stuck on a question, just take a look in the description of this video, and there you'll find some additional resources you can use to prepare for the ASVAB. So all that finally being said, let's go ahead and get started with the practice test. All right, question 1 says, it is 90 feet from home plate to first base on a baseball diamond. How long will it take a batter to reach first base if the batter runs at a rate of 15 feet per second? So right away, you should realize that you have the elements of the distance formula. The distance formula, in case you haven't seen it in a long time, says distance can be found by multiplying rate and time. And of course, D stands for distance, not surprisingly. R stands for rate, and T stands for time. If we look through this problem again, we can see that we have 90 feet as our distance, so we're going to mark that as D. We're told that the batter runs at a rate of 15 feet a second, so that's our R. And we want to know how long. Of course, how long refers to time. So by plugging these three things into our distance formula, we'll be able to solve this accordingly. Again, D is 90 feet, so let's plug in 90 in place of D. R, we were told, is 15 feet per second, so we'll put 15 in place of R. And we're trying to solve for T, so we're going to leave T as T. Okay, so now we're just going to treat this as a one-step equation, and we're going to try to solve for T. To do that, we're going to divide both sides by 15. This, of course, crosses out over here, leaving you with just T on that side. 90 divided by 15. We should be fairly good with our times tables in order to be successful on the ASVAB. So if you need to use your fingers, you can. 15 plus 15 is 30, plus 15 is 45, plus 15 is 60, plus 15 is 75, plus 15 is 90. So in other words, 90 divided by 15 is 6. Of course, in math, it's customary to write the variable for which you solved on the left. So we're going to write this as t equals 6. And of course, since our rate of time was given in terms of seconds, we know time is going to be also in terms of seconds. So in other words, it's going to take 6 seconds for this batter, if they run at a rate of 15 feet per second, to go from home plate to first base, which is a distance of 90 feet. Okay, so you do have to know the distance formula. When I took the ASVAB, I saw at least 3 questions involving the distance formula. Okay, so that's one you do have to commit to memory at some point. All right, this question says, during a sale, 20-cent candy bars were sold at 3 for 50 cents. How much is saved on 9 bars? Okay, so we're buying 9 bars of candy in total. So let's go ahead and see what it would cost us if we paid 20 cents per bar. That would be 0.20, which refers to 20 cents in decimal form, times 9. Again, we're buying 9 bars of candy. When you're multiplying decimals, the trick is to take the decimal and shift it to the right to make that number a whole number. So instead of being 0.20 times 9, I'm going to shift this decimal place 1 2 times to the right to make this 20 times 9 with no decimals, as you can see. And once I get done working this out, I'll shift those 2 decimals back into the left. So 0 times 9 is 0, 2 times 9 is 18. Shift our 2 decimals back in, 1, 2. So as we can see, if we paid 20 cents per candy bar, we would pay $1.80 in total for those 9 candy bars. Now let's see how much we would save if we bought the candy bars at 3 for 50 cents. So 9 divided by 3 is 3, which means we bought 3 sets of 3 candy bars. So we're going to take 3 and multiply it by 50 cents. This is going to be 50 cents times 3. As we did over here, we're going to take the decimal in 50 cents, shift it 2 times to the right to make 0.5050. So this becomes 50 times 3, albeit with 2 decimals to shift back into the left when we're done. 0 times 3 is 0, 5 times 3 is 15. Shift the 2 decimals back in, 1, 2. So here we can see if we paid 50 cents for 3 candy bars, we would pay $1.50 for 9 candy bars. 180 minus 150, you should be able to do in your head. That's going to be 30. So we save a total of 30 cents when we buy 9 candy bars at this discounted price. Okay, so just some very basic work with decimals there, nothing too difficult. All right, this next question says a florist buys flowers at $3 a dozen and sells them at $5 a dozen. How many dozen must be sold to make a profit of $90? So the florist buys them at $3 a dozen and sells them at $5 a dozen. So that means for every dozen she sells, she makes a profit of $2. Again, 5 minus 3 is 2. So if she's making $2 profit per dozen, and we want to figure out how many dozens must be sold for her to earn $90, we'll take 90 and divide that by 2. Again, you should know 90 divided by 2 is 45 if you're good with times tables. That said, let's say you didn't know what that was. You can write this out as 90 divided by 2. 2 goes into 9 4 times without going over. 4 times 2 is 8. 9 minus 8 is 1. We drop down this 0. 2 goes into 10 5 times evenly. 2 times 5 is 10. So we can see there's no remainder. Okay, so in order to make a profit of $90, the florist must sell 45 dozens of flowers. Okay, so that was that one. All right, this next problem says a carpenter uses 12 nails for each board. If there are 48 nails in a pound, how many pounds will be used for 100 boards? So the first thing we have to figure out in order to solve this problem is how many nails are there in 100 boards? Again, there are 12 nails per board and 100 boards. So in total, there are 100 times 12 nails in the 100 boards in total. So let's go ahead and work this out. I know many of you could probably do this mentally, but I'm going to show you the steps anyway. 0 times 2 is 0. 0 times 2 is 0. 1 times 2 is 2. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1. So we have 1,000 plus 200, which is going to be 1,200. In other words, there are 1,200 nails in those 100 boards. All right, in addition, we were told that there are 48 nails in 1 pound. So that's going to prompt us to take 1,200 and divide it by 48. Now, at first glance, you might be saying, this is a pretty difficult problem. Am I going to divide 1200 by 48? You can if you want, but you can also reduce this problem to make it a little bit easier, since both 12 and 48 are factors of 12. So I'm going to divide the numerator, which is 1200, as well as the denominator, which is 48, by factors of 12, which is going to help me reduce this. 12 goes into 12 one time, and I'm just going to drag over those two zeros. 12 goes into 48 four times. Okay? Now the question's much simpler. 100 divided by 4 is 25. You should be able to do that in your head. Again, 25, 50, 75, 100. And just like that, we solve this one. Okay? All right, this problem says a restaurant buys 56 pounds of beef at $1.12 a pound and 24 quarts of milk at 90 cents a quart. How much money was spent? So we're going to take $1.12 and multiply that by 56. And then we're going to take 90 cents and multiply that by 24. When we do these operations, we're going to take the results and add them together. That said, let's take a look at this first multiplication problem. We have 1.12 times 56. In order to make this a little bit easier, we're going to get rid of this decimal by shifting it 2 times to the right. So this is going to become 112 times 56. And once we work this out, we're going to take those two decimals that we shifted to the right and shift them back into the left at the end. So let's go ahead and do that. Take your time as you work this out, because this is where a lot of people would make mistakes, since there's going to be a lot of multiplication to do. 2 times 6 is 12, carry a 1. 6 times 1 is 6, plus 1 is 7. 6 times 6 is 6. Before we start multiplication with this 5, we have to bring down a 0 placeholder. Now we can multiply with the 5. 5 times 2 is 10. Carry a 1. 5 times 1 is 5, plus 1 is 6. And 5 times 1 is 5. All right, let's add these together. 0 plus 2 is 2. 7 plus 0 is 7. 6 plus 6 is 12. Carry your 1. 5 plus 1 is 6. Bring our two decimals back in. Okay, so we know that in total we spent $62.72 for 56 pounds of beef. All right, now let's work this out over here. Again, we have our decimal right here. So to make this math a little bit easier, we're going to shift this decimal in 0.90 2 times to the right to make 0.90 90. So this is going to become 90 times 24, albeit with two decimals to shift back in to the left when we're done. 0 times 4 is 0. 9 times 4 is 36. Before we start multiplication with this 2, we have to bring down a 0 placeholder. 2 times 0 is 0. 9 times 2 is 18. Let's add these up. 0 plus 0 is 0. 0 plus 6 is 6. 8, 9, 10, 11. 8, 9, 10, 11. 8 plus 3 is 11. Carry 1. 1 plus 1 is 2. Bring in our two decimals. 1, 2. All right, now all we have to do is add 62.72 and 21.60 together. So let's go ahead and do that. We have 62.72 plus 21.60. 0 plus 2 is 2. 7 plus 6 is 13. Carry your 1, and this decimal now just drops down in place. 2 plus 1 is 3, plus 1 is 4. And then 6 plus 2 is 8. So in total, the restaurant spent $84.32 on the beef as well as the milk. Okay? All right, this next question says, 2 automobiles start together from the same place and travel along the same route. The first averages 40 miles per hour and the second 55 miles per hour. How many miles further along the route is the second car at the end of 5 hours. That should be farther, not further. So I'll just fix that grammar real quick. But that said, we should recognize that we have the elements of the distance formula. We're given rates, notably miles per hour, as well as 40 and 55 miles per hour respectively. We're given time, a 5-hour trip, and we're being asked to figure out how many miles farther, which is in reference to distance. But that said, let me make a little diagram to help illustrate what's going on here. We have one car, which I'll call car 1. It goes this way, and then we have car 2, which is traveling the same route. Car 1, of course, we're told is going 40 miles per hour, whereas car 2 is going 55 miles per hour. And we're told that both of them travel along this route for 5 hours. So clearly, we have rate and time, so all that's left to find is distance. More specifically, we have to figure out how much further car 2 traveled than car 1. So let's start this problem by writing separate distance formulas for each of these. So for car 1, and I'm just going to note that off to the side here, we're going to use the distance formula d equals rt. And for car 2, we're going to use the distance formula as well. That's, again, d equals rt. So let's fill these in with what we have. We know for both of them, t is going to be 5, so let's fill that in both places. We know car 1's going 40 miles per hour, so we'll fill that in for rate. So we know this is going to be distance there. And then for car 2, we know the rate is 55 miles per hour. And as we can see, by multiplying 40 by 5, we'll get this distance. And by multiplying 55 times 5, we'll get this distance. Let's call this distance 1, since it goes with car 1. Let's call this distance 2. To figure out how much farther car 2 has gone from than car 1, we'll take distance 2 and we'll subtract it by distance 1. So that looks like this. D2 minus D1. Of course, we know what D2 and D1 are. Distance 2, as we can see right here, is 55 times 5. And we can put that in brackets if we want. And distance 1 is 40 times 5. And by figuring this out, we'll figure out how much farther car 2 has traveled than car 1. And if we take a look at our answer choices, we can see that this is exactly B. 55 times 5 minus 40 times 5. Okay, so again, we had to use 2 iterations of the distance formula to figure out how much farther one car went than the other. Okay, so that was that one. Pretty challenging, but nothing too difficult as long as you can think your way through it. All right, this next question says, if 2/3 of a pound of metal costs $6, how much does a pound cost? So one strategy you can use to solve problems like this is by setting up a proportion. And I'm going to set up the left-hand side of the proportion like this. I'm going to put 2/3 in my numerator, and I'm going to write out pounds. And I'm going to place that over $6. And this tells me 2/3 of a pound of metal costs $6. Now let's set up the right-hand side of our proportion and fill it in with the information that we're given. The key to setting up your proportions correctly is to keep your measurements the same. So pounds is in the numerator on the left-hand side of the proportion. So we're going to put pounds in the numerator over here. Dollars is in the denominator here, so we're going to put dollars in the denominator here. So again, how much does a pound cost? So this is 1 pound, and we want to know how much that cost. Since that's an unknown value, we'll represent that as X. Okay, so the next step to solving a proportion is to cross multiply. I'm going to start by doing 2/3 times x. So this becomes 2/3 x. And at this point, you can drop your measurements. You don't need them anymore. And then we're going to do 6 times 1. Anything times 1 is itself. So this is just x. To get rid of this 2/3 in front of this x, we're going to multiply it by its inverse, notably 3/2. This cancels out, leaving you with just x over here. Now we're multiplying a whole number by a fraction. You can rewrite any whole number as a fraction by placing it over 1. So this is the same as 6/1 times 3/2. And when you multiply two fractions, you just multiply straight across. So this becomes 6 times 3, which is 18, over 1 times 2, which is just 2. 18/2 is 9. So in other words, if 2/3 of a pound costs $6, 1 pound cost $9. And we used a proportion as you just saw to solve this one. Okay? All right, so this next question says staples sell for 60 cents a box. How many boxes can be bought for $3.45? If you want to practice using a proportion to solve this one, you can. Again, staples cost 60 cents for one box. That's our left-hand side of this proportion. Let's go ahead and set up the right-hand side. Again, in the numerator, we have 60 cents. So over here, we're going to put $3.45. And we want to know how many boxes, which is unknown. So we're going to call those X boxes. All right, to solve proportions, you cross multiply. So this becomes X times 0.60. So this is 0.60x equals 1 times 345. And anything times 1 is just itself. So this is just 3.45. To solve for x in this case, we're going to divide both sides by 0.60. So this becomes x equals 3.45 divided by 0.60. Now you can regard fractions as long division. So you could read this as 3.45 over 60. Or in this case, you have to read it as 3.45 divided by 0.60. Okay? Now we're trying to solve, and if it's helpful, you can actually drop off this 0 just to make it 0.6, because that 0 is just a placeholder there. So now we're trying to do long division involving two decimals, notably 3.45 and 0.6. As long as the decimal's inside this division bracket, you can proceed. However, if you have a decimal outside this division bracket, which we do, 0.6, you have to shift the decimal in the number that's outside the division bracket such that it becomes a whole number. So to do that, I'm going to take this decimal in 0.6 and shift it one time to the right to make it just 6. And I'm going to shift the decimal inside the division bracket a corresponding number of times. So this is going to become 34.5. And now we can just bring our decimal in place and do this long division as if these were just whole numbers. So now we're asking ourselves, how many times does 6 go into 3? It doesn't. How many times does 6 go into 34? 6 times 5 is 30. 6 times 6 is 36. So we know this is going to be 5. 6 times 5 is 30. 34 minus 30 is going to be 4. And now we can drop down this 5. And we're disregarding this decimal since we already accounted for it. Now the question is, how many times does 6 go into 45? That's going to be 7 times without going over, and as much as 7 times 6 is 42. 45 minus 42 is going to be 3. And now we have an imaginary 0 we can tack on. 6 goes into 30 5 times. 6 times 5 is 30, so we can see there's no remainder. So For $3.45, you can buy 5.75 boxes of staples. And since you're not going to be sold 3/4 of a box of staples, we're going to have to round that just to 5 boxes of staples. Okay? So that was that one. All right, this next question says, if an airplane flies at an average speed of 7.5 miles per minute in 1.5 hours, it will have flown, and we need a question mark there. So again, you might be thinking that we have all the elements of the distance formula, which is true. We have our rate, notably 7.5 miles per minute. We have a time, notably 1.5 hours, and we're being asked how far it would fly, which is distance. So let's go ahead and start by writing down our distance formula. Distance equals rate times time. Let's start plugging things in. We're trying to solve for d, so we're going to leave d as d. Our rate is 7.5 miles per minute, and our time is 1.5 hours. Now here's a problem. We're given a rate in terms of minutes and a time in terms of hours. So if we multiplied this out, we would get the incorrect answer. Rate and time have to be proportional. If something's given in terms of minutes, your time should also be in terms of minutes. Okay? If rate's given in terms of hours, your time better be given in terms of hours. In this case, we have minutes and hours. So at some point, we're either going to have to convert 7.5 to be in terms of hours, or hours to be in terms of minutes. I think it's easier to convert 1.5 hours to minutes. So let's go ahead and do that. Again, we have 1.5 hours. In terms of minutes, this is 90 minutes. Again, there's 60 minutes per hour. Okay, so that's 60. Half of an hour is 30 minutes. 60 plus 30 is 90. Okay, so let's go ahead and correct this right here. So we have it set up to be proportional. And we're going to plug in 90 minutes instead of 1.5 hours. Now this is 7.5 miles per minute times 90 minutes. Again, they're proportional now, so we can just work this out. We can do 90 times 7.5. Of course, we're doing multiplication involving a whole number and a decimal. So in order to proceed, I'm going to take this decimal in 7.5 and shift it one time to the right. That's going to make this become 90 times 75, albeit with one decimal to shift back into the left at the end when we're done. So let's go ahead and work this out. 0 times 5 is 0. 9 times 5 is 45. Before we start multiplication with this 7, we have to bring in a 0 placeholder. 7 times 0 is 0. 7 times 9 is 63. Let's go ahead and add these two things together. 0 plus 0 is 0. 5 plus 0 is 5. 4 plus 3 is 7. 6 plus nothing is 6. Bring in our one decimal point. So we can see that this distance is 675 miles. Okay? A lot of people would get this wrong because they didn't catch on to the fact that this is in minutes, this is in hours. You have to make that conversion at some point to do this one correctly. All right, this next question says, radio station uses 1/6 of its time for news in a 12-hour day. How many hours are used for news? So to solve this one, we're going to take 12 and multiply it by 1/6. Again, as we previously saw, we're going to have to figure out how to multiply a whole number, notably 12, by a fraction, notably 1/6. Again, as I mentioned, you can rewrite whole numbers as fractions by placing them over 1, and then you just multiply straight across. So this becomes 12 times 1, which is 12, 1 times 6, which is 6. 12 divided by 6 is 2. So in other words, if this radio station devotes 1/6 of its 12-hour day to news, that means it's devoting 2 hours of its day to news. Okay, so just some simple multiplication involving fractions there. All right, this next question says workers have packed 1,400 glasses in 7 boxes. If they pack 3 more boxes, how many glasses will they have packed in all? Okay, so the very first thing I want to figure out is how many glasses fit in a box. And to accomplish that, I'm going to take 1,400 and divide it by 7. Again, in these 7 boxes, there are 1,400 glasses. If we work this out, we'll figure out how many glasses are in each box. Thankfully enough, this is pretty easy to do mentally. 14 divided by 7 is 2, and then we'll just tack on these 2 zeros. So there are 200 glasses per box, which tells us that if they pack 3 more boxes, that's going to be 200 times 3 additional glasses. 0 times 3 is 0, 0 times 3 is 0, 2 times 3 is 6. So in those 3 additional boxes, there are 600 more glasses. We want to know how much they packed in total, so that's going to be 1,400 plus 600. This is pretty easy to do without having to work this out, but I'll show you how to do that. 0 plus 0 is 0, 0 plus 0 is 0, 6 plus 4 is 10, carry a 1, 1 plus 1 is 2. So in total, they packed 2,000 glasses. So that's that one. All right, this next question says a store has 600 pounds of feed after delivering. This next question says a store had 600 pounds of feed after delivering equal amounts to 4 farmers. There are 60 pounds left. How many pounds did each farmer receive? Okay, so the first thing I'm going to do is take 600 and subtract 60 from it, because we know there were 60 pounds left at the end of the day. I'll work this out, even though many of you can probably do this mentally. 0 minus 0 is 0. 6 minus 0 we can't do, so we're going to have to borrow. It's going to become 5, and this is going to become 10. 10 minus 6 is 4, and then 5 minus nothing is 5. So this says 540 pounds was distributed among 4 farmers evenly. So we're going to do 540 divided by 4. By working this out, we'll figure out how much each farmer got. Now we're asking ourselves how many times 4 goes into 5. That's 1 time without going over. Given that 4 times 1 is 4. 5 minus 4 is 1. Drop down this 4. 4 goes into 14 3 times without going over. 4 times 3 is 12. 14 minus 12 is 2. And then we got this 0 we can drop down as well. 4 goes into 20. 5 times 4 times 5 is 20. So we can see there's no remainder. In other words, if there were 60 pounds left over, and from the rest, each farmer got a fair share of feed, that means each farmer got 135 pounds of feed, which is D. Okay, so that's that one. All right, this next one says, I shouldn't say number because I didn't number these. This next one says, it takes 15 minutes to fill 375-gallon tank with oil. How many gallons are pumped into the tank in 1 minute? So there are many ways to solve this one, but since I showed you how to use proportions already, let's go ahead and use a proportion to solve this one. We know it takes 15 minutes to fill 375 gallons. And we want to know how many gallons are pumped into the tank per minute. So we'll put 1 minute up here. And again, as we fill in these proportions, we're making sure our measurements are in the same spots. Minutes is in the numerator over here, so minutes is in the numerator over here. Gallons is over here, and we want to know how many gallons. So that's unknown. We're going to write this as X gallons. Okay? So now we're just cross multiplying. I'm going to do X times 15, which is 15X. Then I'm going to do 1 times 375, which is 375. Again, 1 times anything is itself. Divide both sides by 15. This crosses out and leaves you with X equals 375 over 15. And again, as I've mentioned in this video already, we can regard this fraction as long division, notably as 375 divided by 15. Now we're asking ourselves, how many times does 15 go into 3? It doesn't. How many times does 15 go into 37 without going over? It's going to be 2 times, given that 15 times 2 is 30. 37 minus 30 is 7. Drop down this 5. And we should realize that 15 goes into 75 evenly. Again, if you have to, count it out. 15, 30, 45, 60, 75. So that's 5 times. 5 times 15 is 75. So there's no remainder. And as we can see, X refers to gallons in our proportion here. So in other words, if it takes 15 minutes to fill a 375 gallon tank with oil, that means every minute 25 gallons are being pumped into the tank, which is C. Okay. All right, this next question is pretty straightforward. It says, if bricks weigh 4.5 pounds each, how many pounds will 200 bricks weigh? So this is just going to be 200 times 4.5. That said, you have to know how to deal with this decimal. And if you paid attention in this video so far, it should be pretty easy. Again, we're going to take this decimal in 4.5 and shift it 1 time to the right to make 4.545. So in reality, we're working this out. 200 times 45. And once we work this out, we're going to take that 1 decimal that we shifted over here to the right and shift it back into the left. 0 times 5 is 0. 0 times 5 is 0. 5 times 2 is 10. Okay? Before we start multiplication with this 4, we have to drop in a 0 placeholder. 4 times 0 is 0. 4 times 0 is 0. 4 times 2 is 8. And this becomes 0 plus 0, 0 plus 0, 0 plus 0, 1 plus 8, which is 9. Shift our 1 decimal back in, and we can see that this is 900. So 200 bricks, they weigh 4.5 pounds each. It's a total of 900 pounds. Okay. All right, this next question says, on the average, 1 1/3 bushels of seed are needed to plant 1 acre of wheat. How many bushels of seed would be required to plant 30 acres? So not surprisingly, I'm going to use a proportion to make this one a little easier to solve. We know 1 acre of wheat yields 1 1/3 bushels. Okay, so now that we have the left-hand side of our proportion set up, we can fill in the right-hand side accordingly. Again, we have, and this should be acres of wheat. So we have acres over here, and we want to know plant 30 acres. So this is going to be 30 acres of wheat here. We want to know how many bushels that's going to yield. Okay. As you can see, we have wheat in the numerators and bushels in the denominators. So let's go ahead and do the cross multiplication. This is 1 times x. Again, anything times 1 is itself, so 1 times x is just x. Let's cross multiply here. This becomes 1. Let me fix that real quick. 1 1/3 times 30. Okay? And now we can see that by working this out, notably 1 1/3 times 30, we'll know what x is. But that said, we may have forgotten how to deal with mixed numbers, which is 1 1/3, and multiplication. The key to doing this is to convert the mixed number to an improper fraction. So we're going to do 1 times 3, which is 3, plus 1, which is 4. So 1 1/3 is the same as 4/3. We're going to multiply that by 30. Okay? Now we're multiplying a improper fraction or a fraction by a whole number. And as we've seen 2 or 3 times in this video, we can rewrite 30 as a fraction by placing it over 1. And now we just multiply straight across. And we can reduce if we want to, but I'm not going to do that. 40 times 3, or 4 times 30 is 120. 3 times 1 is 3. 12 divided by 3 is 4, and tack on our 0. And so we can see x refers to bushels. In other words, if we plant 30 acres of wheat, that should yield 40 bushels for us. Okay? Right, this final question says a painter needs 5 gallons of paint to finish painting a house. He has 3 quarts and 1 pint. How much more paint does he need? So right away, you should recognize that you're given numbers in terms of gallons, quarts, and pints. So at some point, you're going to have to make a conversion. Before I even get started with this, I'm going to write out the conversions between gallons, quarts, and pints. That way, I have them and I can use them as reference as I work this problem out. So I'm going to write there are 4 quarts in 1 gallon. There are also 2 pints in 1 quart, which means that there are 8 pints in 1 gallon. Okay, so with this written out as reference, we can think about how we want to tackle this problem. I think the easiest way is to convert everything to be in terms of pints. Okay, and that's pretty easy to do. Okay, we have 5 gallons. There are 8 pints in a gallon, which means there are 5 times 8 pints in 5 gallons, which is 40. So 5 gallons is the same as 40 pints. Again, we know right here there are 2 pints per 1 quart. We have 3 quarts, so that's 3 times 2, or 6 pints in these 3 quarts. And then finally, we're told that we have 1 pint, so we don't have to make a conversion there. So what we need to do is add these two together, notably 6 pints and 1 pint, and subtract 40 by that. So that's going to be 40 minus 7. Again, 6 pints plus 1 pint is 7 pints. 40 minus 7 is going to be 33. So we've subtracted 3 quarts and 1 pint from 5 gallons, and that leaves us with 33 pints. Okay, and if we take a look, our answer choices are given in terms of gallons, quarts, and pints. So now we have to take these 33 pints that we have left over and convert them back to gallons, pints, and quarts. Thankfully enough, this is pretty easy to do. Again, we have 33 pints. Let's start by converting that to gallons. Again, there are 8 pints in a gallon. 8 times 4 would be 32. So this would be 32 pints, which is the same as 4 gallons. And that leaves you with 1 pint left over. So 33 pints, in other words, is the same as 4 gallons and 1 pint, which we can see is answer choice C. So that is it for this video. I hope you found it helpful. In all honesty, these problems are pretty simple, but as you saw, you need to be very good with addition, multiplication, subtraction and long division, including with decimals and fractions, to do well on this practice test. And that rings true for the ASVAB as well. On my channel, I do have a reference sheet posted in my community tab. So that's a very good free resource you can use to study for the ASVAB. But that's all I have for you today. And on that note, I'm going to go ahead and cut you loose.
Konnichiwa.